Section 7.2, solving system in two variables. These are the objectives. You can pause to read. I am moving on to the next slide. Number 1 says solve the system by the method of elimination. To clean this up a little bit, I'm going to multiply both sides of this equation by 4. This is what you get. If you keep the variables on the left side and get rid of the integers from the left side, you end up with x plus y equals 3. So this first equation that you see here, once you do a little bit of work, it becomes this. So now you're going to be working with this new first equation and this one. You apply the elimination method, y's cancel, you end up with 2x equals 7, x equals 3.5. You go back and solve for y, use this equation here, and you end up with y is equal to 0.5. And here's your answer. Either one works. Here's number 2. Same directions, but this problem looks a little bit different than number 1. To do number 2, we're going to use the following trick. We're going to let capital X equal 1 over X, capital Y 1 over Y. Once you set up the substitution, so 1 over X is right here, so it becomes 2 capital X, minus 1 over Y, so this becomes minus capital Y, and you should be able to follow how we generate this new second equation into this new second equation. And then at this point, it just becomes very easy problem. What we're going to do is we're going to eliminate. To eliminate, I'm going to multiply the top equation by -2. Once I do that, I notice that these go away, and I'm going to end up with -y equals -1, and I get y equals 1. And this is capital Y. So now I'm going to find capital X. I substitute into this equation. I substitute y equals 1, and I end up with 2x minus 1 equals 0. Capital X. X is equal to 1/2. Are we done? Nope. This is capital Y and capital X. I need lowercase x and y. From here, you should see that lowercase y is the same thing as 1 over capital Y. So once I substitute y equals 1, this is what you get for y. Lowercase y. For lowercase x, substitute capital X, and you end up with 2. So this is your answer to number 2, 2, 1. Get used to using this trick. Let's go to number 3. So again, we're going to use that trick on problem number 2. Once we do the substitution, these are the 2 new equations. At this point, we're going to use the elimination method. I am going to multiply the first equation by -1/2. Once I do that, notice that the y's can go away. At this point, 8x, 16, x equals 2. I find out y, and I use this equation to find y. Substitute x, capital X, y equals -1. So these are my capital letters. Now I need my lowercase. You should be able to follow how we get lowercase x, lowercase y. So here's the answer to number 3. -1/2, comma, -1. Excuse me, rewind. The answer is 1/2, comma, -1. Let's move on to 4. A word problem says one family purchases 5 drinks and 3 churros for $8.50. A second family purchases 6 drinks and 4 churros for $10.50. $2.50. Part A says create a system of linear equations to find the prices of a drink, calling it D, and a churro, calling it C. So here's the equation that is generated by the first family. 5 drinks, 3 churros equals $8.50. Second family, 6 drinks, 4 churros, $10.50. So now, part B says solve the system using any method. Multiply by 4, multiply by -3. Once I do that, I get the following two equations. Notice that the c's go away. So I end up with 2d equals 250, d equals 1.25. You should know how to get c, which is 0.75. It says use a graphing utility to check your result. So what we're going to do is we're going to solve this for c. And you have c is equal to the following. I'm going to solve again this for c. I get the following. This is like a y, and this is like an x. Y, x. So when I plug it into my calculator, this is your y1, this is your y2. So let's first take care of the window. This is the window that I'm going to be using. And again, this is my y1, y2, and this is -5 over 3x. Once I graph this is what I get. And notice that this is giving me the exact value. X is equal to 1.25 and y is equal to 0.75. So a drink costs $1.25, $1.25, and a churro costs 75 cents. We're done with number 4. Let's jump to number 5. Here's number 5. 2 planes start from Boston's Logan International Airport and fly in the opposite directions. The second plane starts half an hour after the first plane, but the speed is 80 kilometers per hour faster. Find the airspeed of each plane if 2 hours after the first planes depart. The planes are 3,200 kilometers apart. This is the formula we're going to use. Distance equals rate times time. This is the information from the first plane. The time is 2 hours. The rate is, we don't know, so we call it r. The distance, total distance is 3,200 kilometers. So it's 3,200 minus the distance of the other plane. So here's second plane. Time is 1.5 hours. The rate is 80 kilometers faster than the first plane, so that's why it's r plus 80, and the total distance is just d. So then, if I apply the formula, I have distance is equal to rate times time, and the same thing, apply the formula, distance is equal to rate times time. I use the distributive property, and this is what you get. At this point, these are my two equations. What I'm going to do is I'm going to take this d, plug it in here. I get 2r equals 3,200 minus this d. Distribute. You should be able to follow the algebra here. I get r is equal to 880. So this is the airspeed of the first plane, 880 kilometers per hour. Airspeed of the second plane is 80 more, so that's how I end up with 960 kilometers per hour. Here's number 6. On Saturday night, the manager of a shoe store evaluates the receipts of the previous week's sales. 250 pairs of 2 different styles of running shoes were sold. One style sold for $75.50 and the other sold for $89.95. The receipts totaled $20,031. The cash register that was supposed to record the number of each type of shoes sold malfunctioned. Can you recover the information of how many shoes of each type were sold? And of course, you would say yes. I'll be more than happy to. So this is what we're going to do. We're going to let A equal B equal what you see there. So the two equations that are generated by the information in the problem are the following. A plus B is equal to 250, and 75.50 times the number of A shoes plus 89.95 times the number of B shoes equals total sales, which you see here. So here are your two equations. I'm going to solve for B. I substitute B in here. I'm skipping some of the algebra there, distributed property, but you should be able to follow. At this point, combine these A's, move them to the other side, take away 20,000 from this side, and that's how we end up with this equation. Divide both sides by this number, and you end up with A is equal to 170, B is equal to 80. At this point, this is the answer to number 6. You can read it. Let's go to the last problem, number 7. This is a very special problem. Now you know why. It says solve the system of equations for U and V. So here are your expressions. This is your first equation. This is your second equation, and we're solving for U and V. So this is what we're going to do. We are going to multiply the first equation by 2 sine 2x, both sides. Once you do that, you end up with this. Now, why did I multiply by 2 sine 2x? You'll see in a little bit. Now, the second equation, I am going to multiply that by. So this is my new first equation. Second equation, I'm going to multiply by cosine 2x. Why am I multiplying both sides by cosine 2x? You'll see why in just a little bit. And this is my new second equation. So here are my two equations. Now, I put them right next to each other. And you should notice that these will go away. And I end up with this plus this equals cotangent 2x. And then at this point, you should see that I have cosine squared 2x, sine squared 2x. Pull out the 2v. This becomes 1, solve for v, and I end up with v is equal to 1/2 cotangent 2x. This is a trigonometric function, but since we're solving for u and v, this is treated like a constant, cotangent 2x. Now, what I'm going to do is I'm going to solve for u, so I use the first equation. This equation that you see here, not this one, or this one. And then I'm going to, where I see a v, I substitute 1/2 cotangent 2x. So once I do that, I get this. And then at this point, when I multiply this, I get cosine 2x. Then from here, I am going to divide everything by cosine 2x. Why? Because like I said a second ago, this is like a constant because we're solving for u and v. Once I do that, this is what I have. U plus 1/2 equals 0, and u is equal to -1/2. And this is the end of the video, and these are your answers. V is equal to that, u is equal to that.